All right. So as Ron mentioned, I just wanted to take some time and sort of discuss, some of the first steps into transforming an automated material handling in your production facility. Um, he kind of summarized who I am, but I've been in manufacturing for over 32 years. I spent my first 10 years with Daimler Chrysler down in Detroit, both in design and manufacturing side of things. I moved from there. I was the owner and CEO of Malibu Boats out of British Columbia, where we designed and manufactured power boats. And then most recently, well, not really recent, 12 years ago, started Konnected Technology. Really from my experience in Malibu Boats, thinking there's got to be a better way to do this and keep control of a manufacturing operation. I am located in British Columbia, but actually in the summer months I live in Kenora, Ontario, so kind of in your guys' neck of the woods. The Connected Smart Factory, we started this company really with the name Connected, with the idea of not reinventing the wheel or reinvesting in automation and technology that you might have, but actually working more to connect it in a way that it becomes more useful or more supportive of the smart factory principles. And so we kind of have two aspects of the business. One is more on the consulting, design, project management side of things and integration, as well as we do design and develop our own systems and production management, sequencing, scheduling, internal conveyance, and a number of others. And so today we're really focused on the internal conveyance and maybe more specifically on the AGV AMR stuff. So first question is, what is an AGV and AMR? And essentially it's an autonomous vehicle that can move materials around your facility unmanned. And there is a distinct difference between AGVs and AMRs, other than cost. And it really boils down to the way that they're navigated. So AGVs were more the starters in this world, and they require magnetic strips or targets or stuff in the facility itself to be able to navigate around, and they follow that distinct path that you've set up for them. In contrast, the AMR, or autonomous mobile robot, uses trackless navigation. So it's using LiDAR and vision systems, et cetera, to really understand its surroundings and know where it can and can't go. So the AMR is kind of the evolution of the AGV. And one of the big benefits it has is it's easy to change or expand what you want to do with the AMR quite quickly, where the AGV would require facility changes in order to make that happen. On the negative side, the AMR is higher cost than an AGV just because of the navigation stuff. So really the burning question is, am I ready for an AGV or an AMR? And I'll use those terms interchangeably. And so when we start with a client, there's really three questions that we start with. Although the AGV is compelling for the potential savings, do you have the correct material handling control system in place? And often that is not the case. And so that makes putting an AGV in quite overwhelming and very expensive to get that other piece in first. Do you have the expertise in place to implement the AGV? There's many examples of companies that bought this new shiny machine to only have it sit in the back corner because it's too overwhelming or takes too much time to get it set up and running correctly. And then last one is really, does it make sense in your operation? Will the AGV have a high enough utilization rate? And is there an efficient system design with your manufacturing flow to help you achieve an acceptable ROI with that installation? So as I alluded to, unfortunately, the answer in most manufacturing operations is they're not really ready for the AMR step yet. And so really what I was going to talk about is what our strategy at Konnected is to help companies get to that point. So just a little bookkeeping here. The agenda, I'm going to talk about the first steps to create the digital material handling plan. I want to talk about some phased approach ideas that we utilize, and then final thoughts and questions and answers. Okay, so the steps to creating a digitized material handling plan. We flow through these steps, and it really doesn't necessarily just pertain to this material handling. It's really for automation in general. So we start with a facility assessment. We create a whole facility strategic plan, very important. Then we move to deployment plan, plan execution, solution validation, then your production deployment and system training. And then the one that gets forgotten a lot is the post-implementation support plan. So I'm going to talk through each of these in a little bit more detail here. So let me flip to this other screen. Okay, so this is actually an excerpt from a customer that we were doing one of these projects with. In this case, it wasn't solely with AMRs. This was more automation in general, but it's the same flow works for both. So we start with the facility assessment, and really, what is that? So that's establishing quality goals, productivity goals. Learning the current pain points from even the operators on the floor, identifying any opportunities for improvements, reviewing the current process and making sure that might be optimized, reviewing the current technology that is already existing in the facility. If you're part of a larger company that has several divisions, reviewing that same automation at other divisions to get some commonality between or best practices. And the other one is to review the current process monitoring practices. In other words, how do we gauge whether we've been successful in doing this or not if you don't have proper monitoring of what results are. From there, we create a whole facility strategic plan. And this is probably the number one most important thing that you can really do when you're starting to go down the automation road. What you don't want to do is automate just little pockets of stuff throughout your facility without the whole plan in place, because you'll end up wasting money and putting stuff in that you can't use later. And so this is very, very important. From there, we move in to the deployment side of things. And so this really, in general, falls in kind of a few different steps here. Looking at process changes, improved implementation of existing technology and automation, introduction of new technology where it makes sense, and then the aftercare support plan. One of the key factors when we are going through each of these steps is creating a very well-defined specification document that whatever feature is being added is working towards. This is very important for a couple of reasons. One of them is if you're going to source out whatever this is to a third party, they can have a much sharper pencil in terms of cost if they know exactly what is required of them. Way too often it's very vague, and there obviously has to be the double it and add 30% to make sure they're covered themselves for all that unknown. So the better you are at specifying it up front, the better they can be at pricing it attractively. The second thing that this helps for is the dreaded feature creep. And feature creep kind of comes in two flavors. One of them is quite good in organic, and that's when you start on these processes and engage other people or shop floor people, lots of ideas start to flow, and some of them are very good to help efficiencies. And so that kind of creep is okay. The other kind, which is if all the use cases haven't thoroughly been thought out and put into the specifications, as you get into this project, you're going to find all kinds of shortcomings that you have to counteract, which ends up costing a lot. And if it's not done very well, it can be a significant runaway cost. And so that's part of the importance of doing all this. And so after that's all created, we then kind of move into the execution phase. And in this particular client, there was an in-house development component. there was parts that we were doing, and then there was other third parties that were doing some pieces. And in this particular role, we functioned as the project management. So even though we weren't doing all the work, we were helping with all the planning side of it and the verification side of it, and doing some pieces of it to make sure that it all came together and the project was successful at the end. And so as all these execution steps and pieces are put in place, we move to a solution validation, making sure that each component functions properly, but also that they interact properly with one another. And then it comes into the production deployment. At that point, we're left with the aftercare support. And so in projects where, you know, there's multiple parties working on different pieces and something does go wrong in the future, there's always a lot of finger pointing. You know, it's your fault, not my fault, that kind of stuff. And we do a lot of work in this area where we function as the main entry point for, you know, issue resolution. And our main job there is really to get to the root cause of it quickly so that we can get the correct parties involved and get a solution in place as fast as possible. So my background's been in the auto industry predominantly, and in those cases, like we do a lot of work with Toyota right now, and they charge $10,000 a minute if whatever you have caused the main manufacturing line to go down. So it's quite severe, and you have to react fast and get to the solution quickly and get it implemented and back in line, because you can't afford that. All right, so moving back to the presentation here. Oops, wrong button, sorry. So we've talked through the first steps of how to create the plan, and then now I wanted to discuss more of the phased approach. So when you're looking at it from a whole facility standpoint, you know, developing and implementing a comprehensive plan, material handling, or any automation in general, in one step can be really overwhelming and therefore very risky to a manufacturing operation. And so at Konnected, we always recommend the phased approach, which really comes in two flavors. One is a staged integration of the technology, and then also implementing in a small subset of work cells, for instance, before you implement it facility-wide. Now, for that all to work properly, you have to have that comprehensive design in place first, so that you prevent any deprecation of early phases with future phases. And so what I mean by that is, if you implement phase one, it's great. You go to phase two, you don't want to have to get rid of phase one in order to do phase two. You want phase two to build, and phase three to build on one and two, etc. Similarly, same thing with personnel training. This is quite challenging with phased approach, but what you want to do is set it so that when you're training for phase one, you're building on the training versus, you know, telling them to forget what they were doing last week and now you got to do this, and then next week change it all again. You don't want to do that, because at the end of the day, you know, the personnel on the floor are key to making this whole thing work. So we're just sort of in the middle of actually working through this with one of our clients, and so I thought I would share sort of in general terms how we did the phase plan with this instance. And so this facility is probably similar to a lot of yours, where it's high product mix with relatively low volume of each of the products. Their current material movement plan within their facility is you know, operator Bob, you know, calling on a phone or calling on a radio to Ken to bring him some more parts when he needs them. And in some cases, those parts are transferred with paper tickets that eventually, hopefully, make it into the ERP system. So in other words, their inventory control within the facility is really lacking. You know, they don't really know where everything is at any one time. And so there's a lot of inefficiency that comes with that. So what we set out in these different phases, which I'll run through this quickly and I have more detail after, is we first set out to digitize the actual material movement within the facility. So get rid of the paper and get rid of the verbal requests for stuff. Then we started to put in some technology to ensure that the proper parts were being moved to the proper cells, so that inventory control became more accurate within the facility. Then working to automate some of those requests coming for different work cells by integrating or getting signals out of the actual work cells through the PLCs, etc. Then moving to helping with the production scheduling. And number 5 is kind of an optional one, but it has a very significant cost impact, at least with this customer, which is your annual or semi-annual inventory counts and cycle count implementation. And then finally at phase 6, they're ready for the AMR piece of things. So going through this a little bit more detail. So what we did in this case is as a first step, there's a dashboard system that the supervisor is actually initiating the move requests in there. So they manually go in there and create a request. It automatically updates, or if it needs to, backflush through the ERP system. So we've gotten rid of the piece where they have to follow up the paper trail and make sure it's implemented in the ERP. So this happens in real time. When any of these tickets are created, it pushes to a handheld device that the material handlers have that gives them basically a list of work instructions that they follow through. And if they pick on any one of these, it's showing them that they need to move this from here to there and the quantity that they need to do. At this stage, there's no barcoding or RFID or anything of parts and or locations in the plant. And so they're just hitting buttons on the device to actually, start the movement and then complete the movement. In the background, or this like everybody knows, like there's hundreds of ERP systems, and they're all pretty much common in that they're really hard to use, particularly when it comes to the plant floor personnel utilizing them. And so the other thing that we accomplished with this stage is kind of building a layer on top of that makes it very user-friendly and simple for them to do the tasks that they do and ensure that they get done correctly. Additionally, with pushing these requests out to the handheld devices, we're able to see the performance of any material handlers or see any material that somehow is stuck in transit and who knows where it's gone, and get it tracked down so that you keep better control of your inventory. Now, step 2 is we want to get better control and ensure that, if we said we had 10 bolts at work cell 1, that there actually are 10 bolts there. And so the easiest and best way to do this really is to enforce scans of parts and locations when they pick up, and again, parts and locations when they drop off. And then automatically update the ERP system live to show that material has moved. When in this particular case, this customer has a policy where they don't actually have dedicated locations for any particular part. They just place them wherever there's free space. And so, as you can imagine, there's a lot of lost inventory in that facility somewhere that they can't find when they need it. And so what we did to help resolve that situation was implement smart tag technology, where these, instead of being paper tags for shelf labels, for instance, they're actually e-ink type tags that update in real time with the latest information. So in this case, if they were dropping this box in this shelf here, they would scan the barcode of the actual e-tag, and it would update with whatever part and quantity that was placed there. As a side benefit, when material handler goes to find those parts again, it can activate a blinking light to help them hone into the actual location quicker. So now we've got fairly good control of inventory, knowing where everything is at any particular time. Now what we want to do is kind of get more into the automation side of things, where we don't have to have supervisor creating these tickets for these finished goods moves, or even the transfer of parts into the cells. And so this is where integration into the work cells, PLC integration, or even if it's a manual type cell, strategies to get that human machine collaboration so that some of these material moves can now be automated. The second piece of that automation is really with assigning the tasks to the material handlers. So instead of always sending these material tasks to Joe, the system will then start to learn where the different material handlers are and which one makes the most sense based on location and workload to actually do the move most efficiently. And if you're thinking about where this is all going, this is completely tying in to the AMR integration down the road, because that same kind of thing has to happen. Something has to tell the AMR to go where it needs to go, and we also need to tell or pick which AMR is the best one suited for that job. So there obviously is some side benefits of the integration of work cells, where schedule and unscheduled downtime tracking, OA, OE performance, quality tracking, all those kind of things can come into it as well. Now with the previous step 3, we have we kind of know what the output of the assembly cells is. Now we want to help with what the input is, and this helps also with making sure stock's transferred in before production starts based on what the production is. This becomes quite important when you have a high variable, high mix, low volume type operation, because production can change, or batches, or however you typically do it. So in a lot of plants I've been in, production scheduling is really based on some well-experienced supervisor and their gut feel and knowledge from the last 20 years as to what to build and to make sure that everything works. But in the vein of efficiency, they often are having to make that decision without all the facts, or without knowing all the factors that are in place. And so that's really what we're aiming to do here. We're not aiming to take away the control of them deciding what gets to be built, but we're aiming to give them all the information that they need to make an informed decision. And so we're looking at what actual production orders have come in, what your inventory of finished goods, what your inventory of components is, what the forecast is, what's the best way to batch it, what ship time is required on this order, and basically present the production manager with a suggested schedule. With that, they can accept it, change it, reject it, do whatever they want, but at least they have all the information available that they can make a decision quickly. And so the other side of what happens here is when the schedule is decided on, we can, if you want, push it out to the cells and then have the operators build those batches based on the time requirements for shipping, etc. So phase 5, I mentioned, is kind of an optional one and really not necessary for the AMR side of things, but what we found is this has a huge financial benefit really for the companies in terms of reducing the amount of time that they're down for whenever these inventory counts happen, and also reducing the manpower requirement to do cycle counts through some automation that we put in place. And so what I'm really talking about here is one with the direct integration with the ERP and scanning. We can schedule and schedule the counts and facilitate them happening kind of much quicker than the traditional paper system. The system does have audits as well to verify. One of the key features that really helps production start faster is we're able to zone these counts. And so when a zone completes, the audit's complete and pushed to the ERP, that zone can actually resume production instead of waiting for the whole plant to finish everywhere. On the cycle count side, we spend a lot of time watching the histories of what previous cycle counts were. And from that can start to generate a cycle count schedule based on the component itself and really the accuracy that it's had in previous cycle counts. And so in general, you can actually start to reduce the amount of cycle counting that you have to do to ensure that your stock count stays good. So now we're finally at the AMR AGV integration step. So when you have all these other steps in place, maybe with the exclusion of 5, you now really are ready to look at the AMR integration piece. And at this point, you have the system in place that's able to give the instructions to the AMR, so it knows what to do. So they are smart machines, but they have to be told exactly what to do, when, and where. Utilizing the phased approach will result in the facility having the required system in place, but it also makes the AMR implementation actually much more cost effective and a higher probability of success if you already have those other systems in place. The side benefit is if you ever have an AMR that goes down, you have a fully functioning system in place that require a little bit more labor, but it's not going to take your facility down or put it into chaos. So there's a few points to consider when implementing AGVs and AMRs. Depending on the application, AMR generally costs about twice as much as a forklift, and that there's a wide variation on that, but in general, that's kind of what it is. Your savings by utilizing AMRs is really achieved through a manpower reduction. Now that being said, AMRs cannot travel faster than 1.5 meters per second by law, and in reality, most of them are about 1.3 down to even 1 when they're loaded. And so this is approximately a third the speed of a forklift driver that is maybe uncontrolled. Some facilities will have forklift speeds and requirements for safety reasons, but in a lot of facilities, the experienced forklift driver can really whip around much faster than an AMR can. When you're looking at implementing an AMR, the route distance and the number of corners significantly impact, the ultimate number of AMRs that you're going to require. On the plus side, though, the AMRs don't require lunch breaks and coffee breaks, bathroom breaks, and are capable of working off hours. So you get a higher utilization hours a day out of an AMR than you would a person. Warehouse space required is generally larger with an AMR than it is with a forklift, depending really on the type of AMR. And the reason for this is generally there's space required between rows of pallets or containers to allow the AMR to access everything properly. And so in some, in open space type facilities, this really probably isn't a huge concern, but in some tight, older buildings with lots of columns, this can eat up a lot of your capacity in a hurry. And the last thing I'm going to mention is, true first in, first out type setups can be challenging with an AMR. It's certainly possible, but what you got to kind of think is that each pickup and drop-off point that an AMR has to go to has to be mapped, and essentially the route in between. And so if you're trying to get to a big warehouse with lots and lots of pallets with first in, first out, and not have some way to shuttle pallets to a lower number of pickup and drop-off points, it makes the integration of the AMR significantly more complicated. So what I'm talking about is, one solution for this usually is gravity feed roller racks, where AMR drops off on one end, they just continually roll down, and they're picked up off the other end when they're moved to shipping or whatever. All right, so now we got through 2 steps. We're going to go to final thoughts. For a successful AMR integration, we've mentioned a few times a control system has to be implemented first that can really orchestrate the facility or material movements throughout the facility. And savings overall savings achieved by actually, automating or digitizing your material movement can be very significant, both in increased productivity and less material lost in the course of production, really. Properly design solutions that consider the ROI as one of the key factors can be scaled to be beneficial to any size company. And so what I'm saying here is you don't have to be a big company to even start to consider this. A system can be designed in any sort of level that can be a benefit to any size company. It might not be quite as high tech, but there certainly is a way to improve it for everybody. Although the implementation of AMR can result in process savings, probably 80% of the savings actually come from implementing the proper control system first. And so what I'm talking about there, like if you want to get to the AMR piece, great, and it probably has some manpower benefits, but the path to get there is going to get you a lot of those savings before you even get to that step. There are many types, shapes, sizes, and manufacturers of AMRs. So when you're considering implementing in a facility, and this is where your whole facility strategic plan is important, you want to get to a point where you have a dispatch system that does not force a specific brand of AMR. And so this is a good analogy of this is really, Apple and the iOS system, or Android and the host of different manufacturers that can build devices for them. And so you don't want to be Apple in the case of AMRs, because what can happen is AMR market is very segmented in terms of each company specializes in a different kind of thing. And so across your facility, you might need several of those different types of AMRs, which means different types of manufacturers. If you end up working with several different dispatch systems, sorry, it creates complete chaos in the facility. It's really hard to manage the traffic. Utilizing the phased approach will reduce the risk and result in the facility having that required system in place for backup, and it will be cost effective when you actually do the AMR integration. On a larger view, in the planning stage, really the project scope definition, project management, validation, deployment, after install support are all very key components to the success of any project, automation, inventory, or otherwise. And as with any process, training is key. Designing an automation plan that builds upon training as opposed to retraining is very, very important. So is it worth getting ready? And I'm probably a little biased in this answer, but yes, for sure it is. You're gonna achieve higher profitability through efficiency. You're gonna have less reliance on staffing. I'm not sure it's a problem in your industries, but in the auto industry, staffing has become brutal. Where you used to have 20-year-long career employees. Now we're kind of happy if they make it past coffee break. So helping with that is, you need less staff if you're more automated, but there's also a reduction in the amount of training that you have to invest in a person before they can be unleashed on the production floor. And then ultimately, this all helps making the company scale easier, when the sales support it. So Konnected Technology, we can help you in multiple ways to ensure a successful project. And we kind of work in all levels of this, whether it's just sort of on a consulting basis, or you want to engage in full system design, if you want to engage in project management, system development, helping with third-party sourcing, new technology sourcing, and then also the after implementation support. And all of works for us. We're just here to help try and get these things to be successful. All right, so that was it, and now we're at the question and answer. So after, if you want to contact me and have more discussion with us, feel free. This is my contact information here.
Well, that's great. Thanks, George. And to those of you that have questions, please use the chat feature. I've noticed that the Q&A feature isn't working. So if you got questions for George, please use the chat. So from what you've presented here, George, in your experience, companies that have purchased AGVs or autonomous AMRs and pushed them into the corner, what would be the three top reasons for that move?
Well, there's I guess it's a relatively new concept in general, and there needs to be a lot of education in it. And so basically what's generally happened is the engineer or whatever has seen a really cool machine, watched the videos, heard the sales pitch, and just went and bought one, not realizing that when they get it on the floor, how do you make it drive around? Like you can make it navigate with following it with your tablet or whatever, but that doesn't really help anything. And so it becomes the realization that, oh, how do we actually get it to work autonomously in terms of arrive at wherever I need it and pick up whatever I want it to do and take it wherever it needs to go. That step becomes, maybe not technically overwhelming, but in the confines of production and all the panics that happen on a daily basis, time to dedicate to it to get to that point where you have the solution for it becomes too much, and so then it just gets put on the back burner.
So kind of shiny toy syndrome.
Yes.
Yeah. That's interesting. That's what you said earlier about, phase one strategy, right? In a lot of cases, when we're looking at newer technologies, running a small scale test, even without a larger strategy in a small area of a plant or R&D facility or whatever, makes a lot of sense. But I guess it's the capital costs of these AMRs that you just don't want to be wrong or you don't want to change direction, put it that way.
Yes.
From phase one to phase two, because that's going to cost you a lot of money.
For sure. Yes, for sure it is. And where possible, you want to commonize your technology in your facility. So that's where it's important to actually look at everything together to see, where the because everything becomes a compromise really with each brand of AMR. They do this right and they do that wrong, or sort of do this or sort of don't do that. And so you need to get to that common ground. Otherwise, you end up with a nightmare even on the maintenance side when you got way too many different types of equipment in there and how they interact, and it becomes very, very difficult to root cause any issues that might happen.
It's interesting. Now, I know a lot of manufacturers I've worked with in the past, they've what you have in stock in the warehouse, right? Because your MRP, ERP system have that. But the minute the forklift picks it up, it's temporarily invisible.
Yeah.
You know that you have that number, but you don't know where it is.
Yeah.
Forklift drops it off in station, and a lot of companies would just disperse directly from the warehouse to the station. And when the station runs out, they call for more, right? Or they just assume that you build a product, therefore you've consumed these, therefore I'm going to deliver you more.
Yeah.
So in your, like, from what I'm gathering from what you talked about here, the first steps of the strategy without the AMRs or AGVs are going to get you substantial better control of your inventory so that you know what you've got in station. Maybe not what have in transit if you're still using forklifts, but maybe. And what you have in station, because you're logging it onto the transport mechanism, you're logging it off of the transport mechanism into the station. Did I understand that right?
Yes, you did. And here's a sort of a real world example. We were in a client's facility and they were having issue back flushing to the ERP. And what their issue is that when they back flush, it won't work because there's not sufficient stock for the part that they already just built, right? And so if you start thinking about, like, how does that happen? If you have inventory control and you built the part, or you didn't have enough parts to build the part, you wouldn't be able to build the assembly, right? But they were already well past that. They've already built the assembly and are after the fact trying to backflush the components out of their inventory, but it's saying you don't have them. And so right off the bat, there's kind of an issue there, right? And so getting back, and it's particularly tough in like components like washers and bolts and that kind of stuff, where you're kind of when your inventory gets to be out of control, the operators generally want to do what's best for the company in terms of building whatever they're supposed to build. So they might just go to the neighboring station that also uses those same bolts and washers and grab a handful, right?
Oh, come on, that never happens.
No, I'm sure it doesn't, but it could, right? Yeah. But so once those types of scenarios start to happen, you're completely out of control in terms of where your inventory is. You might know the total number that's in the building, great, but is it in the right spots? And so what the goal of these first steps is to make sure that the operator doesn't have to make that decision or go to those steps to actually do the production that they need to do. And so that we're ensuring that those components through mins and maxes are there before they actually build. And so this whole backflush issue doesn't ever become an issue, because if the parts aren't there, they wouldn't have been able to build in the first place.
Okay. Yeah. No, that sounds good. So yeah, use the chat feature if you have any questions out there. Now, I'd met a company, this goes back quite a few years, that had an ambitious plan. They were a cabinet manufacturing shop, and their plan was to use AGVs, and a lot of their operations were to glue things together, and then the glue had to sit for a period of time before things went to the next station. And their plan was to assemble the piece, put it on an AGV, have it go get lost at some point in the plant, and then after the 2-hour cure time of the glue is complete, it would fire up and then move it to the next station. And they were going to use their AGVs to time production. Have you ever heard of that before?
Kind of in a failed experiment I have, because not that the idea doesn't work,
Yeah.
but the cost becomes so prohibitive, just having an AMR just driving around for no particular reason, right?
Yeah.
Just to take time. So what we've kind of done in the past in these types of situations is like do an electronic hold on the part so that it can't get into the next station or start to be processed until it's past that time frame.
Okay.
And so you're not consuming all this time, AMR time, having it sit there. It can drop it somewhere and come back and pick it up in 2 hours, wherever the cure time is, and then move it into the next station. But
Okay.
because the AMR is actually scanning the part that it's picking up, well, it wouldn't even be sent the command to pick it up until that time quarantine hold is off.
Yeah.
And so that's probably a more efficient way to kind of do the same thing.
Yeah. And then getting back to what you were saying, the thing that really struck me with when we were talking earlier before your presentation is the fact that your MRP system needs to digitally call and route AMRs. So it's not something where it's on the radio to the forklift to Joe, hey, come pick this up. You have to somehow figure out how to get your production system to properly route and call for parts with supervisor prompts, but not supervisor creating the path that it has to go and where it needs to go, right?
That's really how you're going to achieve the labor reduction that you're after to really justify the expense of the AMRs.
Yeah. And I don't know that there's too many.
You might as well go the full way if you want to really achieve what you're setting up to achieve, right?
Yeah. And I don't know that there's too many ERP, MRP packages that have the ability to be able to do that. Like most of the time, I would assume that you would have to have something developed that lays over your production system to be able to create
right,
those calls.
And the reason for that is to a layman, maybe a manufacturing operation, they're all the same. But in reality, there's not a single one that's same as any other one, right? They all have their intricacies of how stuff's processed and what's important to watch and all that stuff. So that's really why an out of the box ERP solution won't be able to tackle that component of it. It's certainly, the basis of most of what we do, but almost 100% of the time we have to, or the client has to build some sort of middleware solution to kind of take it the final mile. And really, in reality, if you don't, the adoption of it won't stick. And it's going to be 2 months, 3 months, your workers start to figure out, back doors, or we call them leaks, that they can sort of bypass certain things to get the job done, but you then start to lose control over inventory again and all those other things.
Sounds good. Last call for any questions. So if I were to summarize your presentation, is strategically plan the implementation, make sure that your capital choices are future proof, that they can do all the things that you need them to do, and that they're obviously going to be there 5 years from now, parts and those sorts of things. Really look at your internal systems to change them so that they align, they parallel with the requirements of an AMR or an AGV, and then finally buy the AGV.
Yep. And then finally, we're here to help you with any one of those steps if you need it.
Good stuff. Good stuff.
Good. Nope. Well, I appreciate the opportunity, and hopefully it was helpful to somebody.
Yeah, and George, thank you very much. That was extremely helpful. Like I mentioned, we'll be posting this on our website. Should be up either later today or by noon tomorrow. We do have the digital manufacturing trip to Southern Ontario coming up. Some of you that joined late, VTC ended up getting a grant from Next Generation Supercluster to bring a group to Southern Ontario to look at the future of digital material handling, with some tours through some pretty amazing facilities and a AMR manufacturer. So it should be a good couple of days. If you are interested in knowing more about that trip, please reach out and let me know. All right, with that, we're going to end our presentation, and thank you all for joining us.
All right, thank you.
All right, see ya.